Welcome to this explainer. Okay, today we're tackling something every developer relates to. That moment you finally get your Haskell code to compile and run. You're looking at part 128 of Eng's programming notes, and we're exploring a fundamental question. How do you renovate perfectly working code? We're taking a functional text-to-ebook converter and transforming it from something that just works into something completely robust, readable, and totally future-proof. Let's get right into it. Right off the bat, your code finally works, so why on earth would you change it? It's the classic programmer's dilemma. The text-to-ebook code takes parsed text and safely spits out an ebook. Job done, right? Well, not exactly. We're going to treat this code base like a house. Listen, just because the water turns on doesn't mean the plumbing is actually up to code. If we don't upgrade those underlying pipes right now, they're practically guaranteed to burst later when we inevitably want to add a new room, maybe a new feature, or support a new file type. Refactoring isn't about changing the end-user experience, it's about fundamentally rewiring how it operates under the hood so we don't rip our hair out dealing with technical debt down the line. So, jumping into Section 1, the art of refactoring. We're going to break this down into a few core themes today: resilience, communication, readability, modularity, and that ever-present iterative journey of coding. Moving right along to Section 2, building resilient data access. The shift in logic here is brilliant. The old way relied heavily on manual pattern matching. You had to physically map out the entire structure of the args type with all these underscores for fields you didn't even need at that moment. And sure, it seems fine at first glance, but what happens if you add a new argument tomorrow, like a flag for a table of contents? Boom, that hard-coded pattern completely breaks. The whole house comes tumbling down because the function expects a highly specific number of parameters. Now think about the new approach. We shift entirely away from that fragile manual matching and just use dedicated accessor functions like input path args. It's so much cleaner. It makes the code deeply resilient to future changes because we're only asking for exactly what we need. We don't care about the overall shape of the data structure anymore. It totally decouples the function from the data definition, which is a massive win for maintenance. All right, on to Section 3, improving module communication. You know, when modules don't communicate clearly, the whole system ends up doing extra work just to figure out what just happened. Think about the return types. Originally, our convert-to-ebook function was returning an either panduc error and then just a unit type. It's effectively saying, hey, I successfully did the thing, but I have absolutely zero data to give back to you. It's functionally a void. But by swapping that return type to the actual file path, the calling function, like our command line interface, no longer has to blindly guess where the generated file ended up. No more reverse engineering the file name from scratch to find the output. This is a total game changer. It means we can immediately take that confirmed file path and use it right away for logging, or even better, automatically popping open the new ebook in the user's default reader without any extra detective work. Which brings us to Section 4, the one-liner readability track. AIM drops a really great piece of wisdom here. If you can't explain the logic to yourself at a glance, it's usually assigned to stick to simple multiple variables. We've all fallen into this trap, right? The overly dense one-liner. Functionally, replacing the extension by grabbing the input path, mapping to lowercase, and showing the output format all in one line is completely correct. But mentally, it is exhausting to parse. If you actually have to stop your flow to mentally unpack operations piece by piece, that line of code is simply doing too much. Extracting that specific path logic into a clean, separate helper function changes everything. It turns a complex string of operations into a single understandable verb. Plus, it makes testing that logic in isolation a breeze. It's a humbling reminder that code is read way more often than it's written, so we should always optimize for the reader. Next up is Section 5, modularity and error handling. The real magic of modularity is keeping your main converter clean by aggressively separating concerns. If one function is trying to do literally everything, it usually does nothing well, and debugging becomes an absolute nightmare. Look at how clean things get when we break it out. Instead of the main convert-to-ebook function tangling with all the messy details of rendering, we move the PDF generation into its own dedicated generate PDF helper function. It handles 3 distinct sequential steps: compiling the tips template, setting the document options, and actually running the IO command to make the PDF. By isolating these steps, our main function stays incredibly lightweight, and more importantly, we now have a dedicated sandbox. If PDF generation breaks, we know exactly which isolated room in the house we need to check. But this refactoring isn't just about organizing the happy path. This modularity lets us be so much more disciplined with our error handling. As we know, in Haskell, we use the either type for operations that might fail: right for success, left for an error.
By cleanly extracting our PDF logic, we can specifically return a PandaCap error when that left type is matched. Think about how crucial that is. No more silent failures, no more generic crashes that leave you completely lost. We handle exactly what went wrong, exactly where it went wrong, and pass a truly meaningful error back up the chain. It completely takes the guesswork out of troubleshooting.
Let's wrap things up with Section 6, the iterative coding journey.
At the end of the day, writing software is rarely about getting it perfect on the very first keystroke. It's a constant, evolving conversation with your own logic. These core takeaways from Eng's session are basically a master checklist for any project. Future-proof your data by swapping manual pattern matching for accessors. Communicate clearly by returning exact file paths so you aren't leaving your app in the dark. Prioritize human readability. Seriously, beware of those clever but dense one-liners. And isolate your logic and error handling into dedicated helper functions. So, I want to leave you with this thought. Next time you finish a script, the tests pass, and it successfully runs, just pause for a second. Ask yourself this before you hit ship. What working code in your codebase is secretly waiting to be refactored? Is it just functional, or is it genuinely resilient? Don't be afraid to pull up the floorboards and fix the plumbing. Thanks for joining me on this explainer. Catch you next time.